Hi guys, I'm live. I just want to do a touch-up from the concept I mentioned on the calculus video I did. There's something I didn't explain very well, and that's because I didn't understand it, but now I do. So I figured I'd just go live for a second and explain it. So just let me. Calculus is very, very metaphysical. It's very philosophical. It's almost like the art. It's almost the liberal art. Mathematics, if there is one. Let's say in music, you have a concept and then you have the anti or the reverse of that. Like, let's say you're in C major, G is the dominant of C. So, but F is the chord that C is the dominant of, thus making F the anti-dominant. Or maybe we call it subdominant, but really it should be called the anti-dominant. We call it subdominant. Same thing in calculus. With integration and differentiation, the integral of a derivative of the integral of the function's derivative is the function itself, and the derivative of a function's integral is the function itself. Integral and derivative are inverse functions. So that's why intuitively, if you have a line, then the slope of that line is the function which is the derivative of the line, but since the line is the derivative of the area under the curve, because the rate of change or derivative of the area under the curve is equal to the function itself, that makes the original function, that makes the area under curve the antiderivative or the integral of the original function. It's just what is, there's the derivative of the function, which is the derivative of the function, and then there's the function which the function is the derivative of, making that function the integral of the original function. But that's not, if it were just that, that's not why I made this video. I wanted to explain something about the geometry I brought up. So I mentioned, let's go back to geometry and how I applied calculus to it. So, and then apply calculus to the geometry again and see if you can understand what I was saying. So the circumference of a circle is pi times the diameter, or 2 pi r. Well, how do you get the area of the circle? Well, you integrate you start with the circumference of the circle. That's 2 pi r. Then you take a little smaller circle, just a little bit smaller, and if you add that circumference to it, you're starting to get the area of the circle. Because if you keep going little by little, all the sums of the circumferences, if you go all the way to the center of the circle, make the area of the circle. Therefore, the area of the circle is the integral of the circumference of the circle, and that's why if the circumference of the circle is 2 pi r, to get the area of the circle, you raise r to the second power and then divide by that, making pi r squared, because that's the rule of how to integrate or differentiate a polynomial or monomial. But that's what you do. If you can understand what I just said, it actually is true. Whether it makes sense or not, I'm not sure. But the same is true of the sphere. So I said that the surface area of a sphere is 4 pi times the radius squared, or 4 pi r squared. But that surface area, if you add a little smaller surface area inside that, and you get another surface area, and you do another one a little smaller than that, you start to get the volume of the sphere. If you add enough surface areas, starting from the radius going inward to 0, you eventually fill up the sphere and you have a volume of the sphere. Therefore, the volume of the sphere is the integral of the surface area of the sphere. And since the surface area of the sphere is 4 pi r squared, to get the volume of the sphere, you just take the power up by 1 to make it r. This makes the third power of r, and then divide by that. So that's why. That's why the volume of a sphere is 4/3 pi r cubed. Because if you start with 4 pi r squared as the surface area, and you integrate enough of them and add enough of them up, and then the integral of that monomial is 4/3 pi r cubed, because you've raised the power to 1 and divide by that. So the volume of the sphere is 4/3 pi r cubed. Only thing I didn't really explain is what I'm not really sure is how would you know that there's 4 that the surface area of a sphere is 4 pi r squared, or 4 times the the area of a circle with the same radius. I'm not sure about that. So anyway, love you guys. Peace, love, rock and roll.